Hello everyone, welcome to my final project presentation. Today I'll be presenting the development of my generative chatbot using sequence-to-sequence approach. My name is Shruti and I am a student at University of San Diego doing Masters in Applied AI. In this presentation, I'll walk you through the project's objectives, methodologies, the challenges I faced and the chatbot's final result. So let's start. The chatbots have become increasingly significant in various industries, from customer service to healthcare, providing 24/7 automated assistance. Their ability to simulate human-like conversations make them essential tool in enhancing user engagement and operational efficiency. So the goal of my project was to build a generative chatbot that can engage users in a human-like conversation based on a Cornell movie dialogue dataset. So the project had several objectives. First, I aimed to develop a generative chatbot that could generate responses dynamically rather than relying on a predefined answers. Second, I used the Cornwall movie dialogue dataset to train this chatbot. Additionally, I built a simple web interface to allow the real-time interaction with the users. Finally, I aim to evaluate the chatbot's performance and identify areas for future improvements and scalability. For this project, I used the Cornell movie dialogue dataset, which consists of over 2 lakh movie dialogues. Since training on the full dataset was computationally challenging, I worked with a sample of 30,000 records. Pre-processing involved cleaning the text by removing unnecessary punctuation, tokenizing words, and padding sequences. That inputs to the model had uniform length. So this step was crucial in ensuring the chatbot could process and generate responses effectively. And one more thing, stemming and lemmatization were not performed during the pre-processing, as this is a generative chatbot. In generative models, it is important to retain the natural form of words to generate the human-like responses. Applying stemming or lemmatization would reduce the words to their root forms, which could hinder the chatbot's ability to produce grammatically correct and contextual appropriate sentences, especially in case of conversational settings where word variations are crucial for maintaining natural dialogue flow. Through exploratory data analysis, I examined patterns in the dataset. The top 10 words included common words such as you, I, and the. Sentence length was also analyzed, with most dialogues containing fewer than 10 words. This analysis informed my approach in designing the chatbot model, helping to focus on handling short but meaningful conversations. The core of my model is a sequence-to-sequence architecture, which is ideal for tasks like chatbot development, where the input and the output sequences are of different length. The encoder processes the user input while the decoder generates the responses. Long short-term memory LSTM layers were used in both the encoder and decoder to handle long-term dependencies in the data. And softmax activation is also used for the predicting the text. I also experimented with various models, including the basic sequence-to-sequence architecture and transformer-based models. I also explored pre-trained large language models like GPT-2. However, due to the large size of the dataset and the computational resource limitations, fine-tuning these models was not feasible for this project with the free resources available. The sequence-to-sequence model with LSTM proved to be the most computationally efficient, though future projects with more resources could further explore transformer-based approaches. So now let's see the demo of chatbot. So here is the demo of the chatbot in action. So let's start. So as you can see in this example, when the user types a message, the chatbot is able to provide the response based upon the training. So let's see how it is in the web interface that was built using the Flask application. This is a basic web interface which I built locally using the Flask application. So as you can see, the chatbot is able to provide the responses here as well, based upon the model training which we have done with the sample dataset. So the chatbot can handle the basic dialogues easily, and it can generate the responses like human. To evaluate the model, I tracked metrics like accuracy and loss. The loss decreased steadily during training, indicating that the model was learning from the data. Even though the accuracy was good, since the dataset is small, it is reflecting the inherent complexity of generating conversational responses. The training time was also a factor due to computational limits. With more data and resources, I believe these metrics could be further improved. So in terms of the future improvements, expanding the dataset beyond 30,000 records would provide the model with more training data, allowing it to generate more diverse responses. Additionally, future projects could explore using transformer-based models like GPT, which are better suited for large-scale language generation tasks. Finally, deploying the chatbot on a cloud platform would improve its scalability, and enhancing the web interface would provide a more seamless user experience. Finally, to wrap up, this project has successfully achieved several key milestones. I was able to build a fully functional generative chatbot using sequence-to-sequence architecture with LSTM, trained on a sample of the Cornell movie dialogue dataset. I also developed a web interface for real-time interaction, allowing users to engage directly with the chatbot. Though there are limitations due to the computational constraints and dataset size, the chatbot performs reasonably well for basic conversational tasks. In terms of real-world application, this chatbot could be adapted for industries like customer service, healthcare, and e-learning, where conversational AI can automate interactions, provide information, or guide users. With further development, including scaling up the dataset and improving the model architecture, the chatbot can be refined for more complex dialogue tasks. I would like to highlight that I was a sole contributor to this project. I was responsible for every aspect of the development, from data pre-processing and exploratory analysis to designing and training the model. I also created the local web interface and conducted the evaluation and testing of chatbot. Throughout the project, I worked on understanding the chatbot's response behavior and tried to refine the architecture to improve its conversational abilities. The process was highly educational, providing valuable insights into deep learning and AI-driven conversation systems. Finally, I would like to thank Professor Heiser and the faculty team for this opportunity, and thank you all for your time and attention. I hope this project highlights the potential of generative AI in conversational interfaces and opens up possibilities for further exploration in this field. Thank you.